to Module 6 of IT Project Management. In this module, we'll pay special attention to one of the most tricky issues in project management: project scope management and requirements, both in a waterfall and in an agile environment. In this part of our module, we want to understand the 5 processes that support project scope management as defined by PMI in the PMBOK guide. And we also want to understand the difference between product scope and project scope. Lastly, we want to learn how to apply several tools and techniques for defining and managing the project scope. Being directly derived from a project's measurable organizational value, project scope sets out the work boundaries and the deliverables of a project so that what needs to get done will get done, but only that and nothing else. So in other words, project scope defines all the work and all the activities and all the deliverables that the project team needs to provide in order for the project to achieve its intended measurable organizational value. How is scope documented? Scope is often documented as part of the work in the work breakdown structure. And that is our goal at the end of this module. A work breakdown structure then is a documentation of how work can be organized in order to achieve project scope. The work breakdown structure is essentially a project management tool that gives us a hierarchical structure for the work that needs to be done in order to connect a project scope with its detailed work plan that we can create later on. This graphic does a great job of putting into context the relationship between project scope and product scope. Now, to remind ourselves, project scope, here shown in the blue rectangle, is the work that we need to accomplish in order to deliver the product, service, or result that the project intends, with the specified features and the functions that the project intends, in order to build and deliver the measurable organizational value that we're supposed to deliver. Much of project scope management happens in the planning and in the monitoring and controlling phases. This starts with planning the scope management, collecting requirements, defining the scope, as well as then taking the requirements and that scope definition to figure out what the work is that needs to occur in order to deliver that scope. This is what is involved in the create work breakdown structure, or create WBS stage here. And then in the monitoring and controlling phases, of course, we're going to validate our scope, which means we're testing whether we have built the right thing and whether we have built what we have built correctly. And then we're also, of course, always controlling the scope in order to determine that we're building only what is in scope and not what is out of scope based on the scope definition in our project charter. Now, in the planning phase for project scope, some of the assets that we produce are the deliverable definition table or the deliverable structure chart and the work breakdown structure or the WBS. And in the monitoring and controlling phases, we have our scope change control process that has a lot to do, of course, with our overall project change control mechanisms from our project integration knowledge area. So then we have our product scope, which is here shown in the white rectangle. Our product scope comprises the features and the functions that characterize our product, service, or result, which means those would be the technical requirements. This would be our product design in terms of a context diagram, for example, that shows the data flow, or in terms of a use case diagram that shows how actors interact with our system to determine what functionality we need to build in order to deliver these desired actions. In order to verify our product scope, we use test plans, specifically verification cross-reference matrices called VCRMs, that determine whether we have built a product that actually works as intended. Yeah, so let's talk about scope creep. In order to produce a project measurable organizational value, we typically have what we call a balance between scope, schedule, and budget, meaning we have determined what we're going to build, and based on that amount of functionality that we are going to build, we have estimated a budget that we are going to use to pay for the generation of this scope. And based on the budget and the scope and the people that we have available, we have built a schedule that will allow us to finish building this scope, and only this scope, on time and within this budget. Now, of course, there will be cases where somebody will approach you, maybe an executive, maybe another very influential person in an organization, to say, hey, while you are building ABC, could you just also build me XYZ? It really isn't that much extra work. That would mean that our scope would increase, but what would not increase would be the budget or the schedule, which means that we would have to do more than intended with the same budget and the same schedule. And that introduces an imbalance into this triple constraint on the one hand. On the other hand, of course, it means that we are going to introduce a risk to our budget management and to our schedule management. So the only correct answer to this is that, sure, we can build you XYZ while we're building ABC, but we're going to first have to evaluate the impact on our budget and on our schedule. And then we're going to put together a change request in order to adjust our scope so that we can ask for any extra funding or for any extra schedule that it will take to complete the project on time. That is the typical acceptable way of introducing extra scope into your project. In other words, it takes an approved scope change management process in order to adjust scope so that budget and schedule can also be adjusted. And these change requests have to be authorized by the project sponsor. A change request is an addition to the project charter and modifies parts of the project charter. So here, if scope is increased, it modifies the scope statement as it is recorded in the project charter. This is why any changes to scope and to budget and to schedule will have to be authorized by the project sponsor first before they can be implemented. Here we are looking at the project scope management knowledge. Here is a great overview of all the processes of project scope management. Please pause this video here and read through this list. As I have mentioned before, the project scope statement really is an expanded version of the scope statement as it is located in the project charter. That's because the scope statement and the project charter have to be traceable from one to the next. The project scope statement also contains a deliverable definition table or a deliverable structure chart that contains the assets that need to be generated throughout the project scope. And then here in our case contains a context diagram and a use case diagram, both of which address the technical product scope, since the product scope is a major part of the entire project scope. Lastly, the scope statement also needs to include a reference to the scope change management process or a description of the scope change management process in itself. That's important in order to avoid scope creep and in order to show the correct way of adjusting project scope should change requests and the change request process be needed. Here we're seeing two ways of documenting project scope. On the left side, you're seeing a deliverable definitions table. The deliverable definitions table contains the project deliverable, here for example, project charter and project plan, and so on. The structure of that specific deliverable, in our case it's all documents. Then the approval structure in alignment to our project governance structure. And the resources required, that is the roles that are in charge of producing this kind of deliverable. Now, please note that in this project deliverable definition table, we also see the product scope. For example, requirements, physical design, and logical design. That is because product scope is part of project scope. And we're seeing the same thing in a different structure on the right side of the screen in a deliverable structure chart. The deliverable structure chart is a hierarchical model in which we're seeing the 5 project phases on the first level of the tree. And we're seeing here in the white rectangles the specific deliverables to the individual project phases, and then we're seeing under execution and monitoring and controlling the deliverables that are aligned with the software development lifecycle of analysis, design, build, test, and implementation. And this is another way of showing all the deliverables that are required for a project. In other words, here we're seeing the project deliverables on the first level of the tree, and then the software development lifecycle deliverables on the second part of the tree, the second tier of the tree. But all of these are required in order to fulfill the entire project scope. Now, going into product scope, which is, as we have seen, a subset of the entire project scope, we are looking at, for example, software requirements. Here on the left side, we're seeing 3 levels of software requirements, starting from business requirements that then lead to the generation of the business case and the project charter, to the use case documentation, then that leads to the functional requirements, that is the requirements of how the software or how the product or service is supposed to function. That includes system requirements, quality attributes, and then that leads to the software requirement specification, in which each software module is described exactly based on the functional requirements that are being passed down through the use case documentation, and that also take into account the necessity of interfacing with external applications through APIs and any other constraints in terms of operating environment, operating systems, and so on. So as we're looking at the green rectangle, namely the scope as it is documented in our business case and in our charter, at this level, this is where our project scope statement lives. Our project scope statement then specifically contains the product scope statement part that consists of a context diagram that we're seeing on the top right hand. The context diagram shows us here, for example, with an e-commerce banking system, the data flow and the ways in which information goes from one module or from one external system to the actual system that we are supposed to be delivering. A second way of documenting the project functionality, in addition to the context diagram, please note that in a context diagram the system is always shown in a circle, is the use case diagram. In the use case diagram, in contrast to the context diagram, our system is always shown in a rectangle, and we have these little mannequin figures that are called actors, and either humans interacting with our system and performing specific activities on our system, as we can see in those ovals that are connected to the little mannequins, or they are other systems that interface with our banking system through APIs, and those interfaces and interface activities are also documented in rectangles. Both of these together, the context diagram and the use case, or a whole number of use cases for any kind of interaction that actors have with our system, typically that's an entire database full of use cases, make it possible to develop a detailed design and a software requirements specification that we can then pass on to our development team in order to build for us the e-commerce banking system as designed based on user requirements, business rules, system requirements, business requirements, and quality attributes, all of which lead us to these two or more diagrams that then allow us to be very specific in the documentation of the code that needs to be written. Here is another look at a use case diagram. As we have seen before, the system itself is always shown in a rectangle in a use case, and then we have our actors outside of our rectangle because they interact with the system. Actors can be people such as a customer or a manager, but they can also be external systems as shown here, an ERP system, for example. The activities that our actors perform on the system are shown as ovals, or are shown inside of ovals inside of our rectangle. They are always connected with the actor who performs these actions. Here, for example, our customer wants to view check images, change the address, get branch information, and so on. Our manager wants to print reports, and our ERP system, in order to process data further, wants to get account information for a customer, we're going to assume, and then update account balances. No matter whether you start with a use case or step right into technical feasibility, requirements provide a common understanding of what the solution needs to do to satisfy the stakeholders' needs. A complete requirements package documents the overall strategic business need, user and stakeholder needs, and a description of what the solution needs to be able to do and how well it needs to be able to do it. Effective requirements documentation is both high-level and detailed. The high-level view shows the boundary of the system or process that is being changed. The details describe specific business rules that will govern the actions of the solution. Therefore, a complete requirements package may contain many different components, such as personas. Personas describe the various types of stakeholders that engage with the process or product. Each persona includes attributes and interests that enrich our understanding of the users. User stories. The collection of user stories forms the detailed stakeholder requirements. Process maps. A cross-functional model of the activities within the scope of the project. Current state process maps capture how the work is done today, and future state models describe the desired improvements to the process. System models. System models are graphical representations that illustrate relationships between people, systems, and data. Deciding on a format and technology for requirements documentation is usually based on organizational standards, the size and scope of the project, and availability of technologies such as requirements management applications. A spreadsheet application like Excel can provide the ability to sort and filter the requirements for further analysis and reporting, and also for requirements capture. Now, well-written requirements provide the basis for testing whether the product was correctly built. But how do we test the requirements? Validation and verification are the terms we use for making sure the requirements are correct and that the product meets requirements. Validation is primarily focused on ensuring that the requirements deliverables are correct and complete. Requirements are reviewed with the stakeholders using a variety of techniques, including inspections, walkthroughs, and prototyping. Verification is primarily focused on ensuring that the product was built correctly and is functioning as designed. Verification is typically performed during the construction phase using tests and inspections. These activities will be performed by a range of team members, including the analysts, designers, developers, and testers. While requirements become clearer and more known throughout a project in a process called progressive elaboration, it is very important to document them correctly in a project backlog or a requirements register. For IT projects, there are many different kinds of requirements documentation templates out there, depending on the nature of the project. Here in the blue box to the left, you are seeing the document structure for new software development, a software or system requirements specification. Look at the bullet points in system features, external interfaces, and concerns queries doubts. All of these will have to be addressed and later on managed, because all of these will have to be testable later on, and the software and hardware requirement trees to the right show exactly that. This is why smart project managers will immediately involve software testers when it comes to collecting and writing requirements for a product. Writing test plans as soon as you write requirements means that your product will be built with attention to quality so that it can later on pass its testing stages. We have just discussed the entire path of scope definition from the initial scope statements as shown in the project charter all the way down to the software requirements specification in which every single little software module is expressly defined. That is one way of looking at scope, but how do you know whether you're not losing your way somewhere in there? This is where the validate scope process comes in at the end of our development process, because in order to determine whether we have built the right thing and we have fulfilled all of our scope items that we set out to build, we need to validate each one of these items. This includes verifying all of the MOV. In other words, has the project's MOV been clearly defined and agreed upon such that we have built the right thing? Have all deliverables been properly documented? This means, do we have a software requirement specification? Do we have an architectural diagram? Can we trace back the code that we have written to an item in the diagram? And do all items that we have built support the project's measurable organizational value as originally described? Part of validating the scope then are also the quality standards. Namely, are controls in place to help us determine that the work that we have done was done based on specific quality standards, based on specific legal requirements, and so on. And then, of course, since we're validating not just product scope, through testing, but we're also validating project scope. We need to validate that all milestones have been defined in the project delivery cycle and that all milestones have been agreed upon as well and approved by the project sponsor. Lastly, we need to always make sure within the validate scope process, which is not just something that happens at the end of our build and our design and build phase, but really that happens throughout the entire project life cycle. We always need to check back with our stakeholders that everybody knows exactly what to expect during the entire development cycle. Because when expectations are unclear or not aligned between the project team and external stakeholders, then scope creep can occur. We've already talked about scope creep as that request of, oh, while you're building ABC, can you also build XYZ for me? Now here is the actual change request process that needs to occur in order to add scope XYZ to the already agreed upon and documented scope ABC. Because any kind of requested change adds on to the project charter. As such, we need what is called a scope change request form, which is what you're seeing here, in which the impacts of any change requests on schedule, on resources required, that includes people's work time, and on project budgets are being evaluated. And then a recommendation is given. And this scope change request form, which can be on paper, it can be electronic, then has to be authorized, and it has to be authorized as a supplement to the project charter because it modifies the project charter. So the only person who can authorize a scope change request has to be the project sponsor. No scope changes without project sponsor approval. And because each change request is a modification to the project charter, we need to log all the scope change requests with the request number, the request title, and the date, the priority, whether that scope change request was approved, when we expect it to be approved, and who approved it. That's very, very important because remember, any change request is a modification not just to project scope as stated in the project charter, but it is also a modification of the project budget. And more often than not, a scope change request also will extend your project schedule. Let's take a quick look at project and product scope in an Agile context. So what's the big difference between an Agile project environment and a Waterfall environment? Well, in a Waterfall environment, we have to be absolutely sure about what we're building. That's why we have, in this course, spent quite a bit of time on scope definition and scope documentation, and we know that in a traditional environment, scope does not change until you collect all the information and file a change request with the project sponsor. This project sponsor then has to approve the change request to adjust schedule and budget to expand or contract as scope gets bigger or smaller. That's what we call the predictive lifecycle model or the waterfall lifecycle. However, what happens if our client does not exactly know what they need or if we're building something completely new that is in some ways explorative? Then we have a higher percentage of uncertainty in our project. That is where a more change-driven, adaptive model might be more appropriate to use. This change-driven, adaptive model is sometimes called the Agile model, sometimes it's called the iterative model, or in some cases just Scrum, which is one of the methods used in an Agile environment. Agile models are typically iterative and incremental. The basic idea here is to develop a system through repeated cycles, that's iterative, and in smaller portions at a time, that's incremental, allowing the developers to take advantage of what was learned during the development of earlier parts or versions of the system. Learning comes from both the development and use of the system, where possible key steps in the process start with a simple implementation of a subset of the software requirements and iteratively enhance the evolving versions until the full system is implemented. At each iteration, design modifications are made and new functional capabilities are added. Again, this is the adaptive nature of the Agile model. What I have seen most in organizations is a mixture of the two models, of predictive and adaptive into a hybrid model. Here, parts of the project are managed as waterfall, especially when it comes to the early nailing down of scope or to the closing phase. But the actual production, the SDLC, from the design phase onward, is often developed and delivered iteratively in order to develop and test a product in small increments and make last-time changes and big fixes easier. This often leads to interesting vocabulary issues, especially around the requirements or backlog. This is why it's important to know both kinds of terminology. So what exactly is Agile? To use the definition from the PMBOK, Agile is an iterative, team-based approach to development which emphasizes the rapid delivery of an application in complete functional components. The Agile lifecycle starts with a product vision. This vision is generated by the product owner, whose role is a mixture of the traditional project sponsor and the project manager, in that she's entirely in charge of project scope. The product owner then communicates her vision to the team in user stories. User stories describe the product scope and have a very similar function to requirements in a traditional project lifecycle. These user stories are collected in the product backlog. Each one of them is a little cube here, and then prioritized by the product owner and estimated by the technical team based on technical complexity and work effort. So far things don't really seem all that different from traditional activity duration estimates, right? But then the magic happens. Then the team, in collaboration with the product owner, determines, based on the priority and their estimates, how many of these user stories can be developed in a 2 to 4 week sprint and deliver a workable product. These selected user stories then go into the sprint backlog. And then, every morning, the development team meets in front of a whiteboard in a 15-minute stand-up meeting, in which each member answers 3 questions. What did you do yesterday? What are you going to do today? What help do you need to get your work done successfully? After this Scrum meeting, the developers decide themselves what work they're going to do for the next 24 hours so that they can come back in the next day and report progress. At the end of the sprint, which is the time box of 2 to 4 weeks, how long it exactly is what the product owner determines at the start of the project. The expectation is that the team will deliver a working, tested, shippable product. They demonstrate this product to the product owner in a meeting called the sprint review. In the sprint retrospective, which comes as soon as the sprint review is over and hopefully the product is approved, the team evaluates their progress and the effectiveness with which they have completed their work in this sprint. As you have just learned, the entire Agile process starts with scope identification. Here, that means imagining how the end user would use your product. Quite often, this is where end users get to weigh in significantly through feature surveys, workflow observations, basically anything that helps the product owner envision what the product should be like so that it generates the biggest measurable organizational value. All the ways in which the system is being used are then captured in user stories. Writing user stories is hard. They have to be short, typically no longer than one sentence, so they can fit on a sticky note or a flashcard. They have to be written in the language of the end user, not the engineer or developer, to ensure that the words used show exactly what the user wants and how and why they want it. Once they're done, these user stories are collected and indexed in the product backlog. Each one represents, so to say, a part of a conceptual model. The technical team then takes the user stories, that is the conceptual model, and uses them as the basis for greater elaboration into a technically more detailed design that can be built by an engineer or developer. To make the handoff between the product owner and the technical team easier, user stories have a specific format. It typically goes like this: as a, and then insert the end user's role or job title, I want, and then describe the action that they want to take, and then so that, to give the reason why they need to take this action. This very specific grammar allows technical personnel to easily write test plans for a particular role and focus on the feature that needs to be tested, and on the larger technical integration or workflow context. Here are a few examples. See how they follow this format? In the first example, the role is the user, so that story goes into the test plan for the user role. In the second story, the role is the administrator, so that test plan goes into the administrator role. In the user role test plan, we then write exact test steps for photo uploads. We also connect this story with another story that seems hidden in it, namely a photo sharing feature. That photo sharing feature will need its own story, of course, and will need to be connected to the upload screen in some way. The administrator story also contains a hidden story that may need even further elaboration. In other words, we need to ask questions about the word appropriate. Does the user want just an appropriate-inappropriate switch? Or age range levels, for example, appropriate for adults, inappropriate for children, appropriate for upper level management, not appropriate for individual contributors, that kind of thing? Or perhaps appropriate only for certain roles that exist in the organization's directory server? In other words, the last "so that" phrase can really be nothing or mushroom into a really big work effort. These questions of scope need to be clarified between the team and the product owner and the business level, at the latest in the sprint planning meeting. As we said before, the product owner stores user stories in the product backlog. The nature of this backlog depends on the product and on the organization. Sometimes you will find just the user stories with their index numbers, as in the example to the right. Sometimes you might already find some very technical requirements. That is especially true if you're working in a hybrid Waterfall Agile environment in which the scope has already been more clearly defined in a scope statement or use cases during the initiation phase. Look at the rightmost column in the example. This is where you see the priority column. Here the product owner assigns priority numbers to the user stories and their implicitly connected features that she wants the team to build first. As you see here, the database of the user stories is in fact sorted by the product owner's priorities. Then there's another really important column, perhaps the most important column for all the technical people on the team who are going to build the product, the estimation column. As you can see, this column contains numbers. These are called story points. Story points are estimates of effort. They depend on the amount of work required to build the user story, the complexity of the work, meaning how hard it is to build, and the risk and uncertainty, especially if this is something the team has never built before. So what about scope change management in an Agile context? Do we still have to control scope? Yes, we do, but the product owner is in charge here. You're seeing the backlog on the left side of the screen here. The product owner can decide to change priorities between sprints. She can decide to add new items to the backlog. The point here is that the product owner and the team work together on deciding how many story points are estimated by item in the backlog, so that only the items that will actually fit into a sprint go into a sprint. So for example, the product owner could decide to change priority number 5 to priority number 10. That's estimated at 2 story points. And we're seeing that priority number 10 is also estimated at 2 story points. So that is an even change. That's great. But what if we want to switch, let's say, priority 6 and priority 7? If we switch priority 7 to priority 6, that's 2 story points. But if we switch priority 6 to priority 7, that is 5 story points. So that may either underload the sprint for which the previous priority was planned, or it may overload the sprint for which this priority is planned. The point is that this is between the product owner and the product team. And yes, as I said before, the product owner can add new backlog items, but again, then she must provide the available funding and an available spot in the sprint in which she wants to allocate any new product items. In this module, we have looked at the 5 processes that support project scope management, and we have spent quite a bit of time on collecting requirements. No matter whether you're in an Agile or in a Waterfall context, it's important to get requirements as correct, specific, and comprehensive as possible at the start of a project, because that sets the direction for your further planning. Of course, you'll want to be aware that product scope can change along the way, while project scope remains more or less stable. If your product scope changes, these changes have to be documented. In a waterfall environment, you use a change request process to make these changes happen. And in an Agile environment, changes can happen from sprint to sprint depending on the product owner's priorities. Thanks for watching. I look forward to seeing you in the next video.